carry out this entire session. It's not very good today, so if I start sounding bad during the end, bear with me, please. Today we will talk about how we built a Raspberry Pi wall and used it for very affordable performance tests. We will start with the background. Why did we do this? The alternatives we considered before going for the Raspberry wall. We look at the implementation and some of the nasty things that can happen there. And we will do a live demo. Hopefully it will work out. And finally, the results we got and time for questions. However, if you want to ask a question, just wave your hand or scream at me or something. It's much better to break and take the question right away. We should have time for that, so feel free. Who am I? My name is Erik Wramner. I've been doing software development for quite some time, and I worked with Java since 1997. And I've also worked a lot with performance tuning, so that's where this comes in. Our company CodeMint is a small consulting firm. We are based in Gothenburg. We do a lot of Java development, and mostly with Oracle's technology stack, but by no means exclusively. And we often do performance tuning as well for our applications. In one assignment, we were asked to build a network server. It had very high uptime requirements, so basically no downtime at all. It also had fairly high performance requirements. We needed to have 50,000 concurrent and long-lasting connections. And we needed to sustain 100 business transactions per second, so fairly high load. The server used both a custom binary protocol and SOAP, and the security requirements were quite strict. So we thought about how would we ensure that this server actually worked correctly. And we considered the normal alternatives: a single server, developer workstations, the cloud, of course, and finally I thought about the Raspberry wall, which is what we actually went for. The most common approach, if you want to load test something, is to get a server for it. And if you are very, very lucky, you will get a dedicated server. Most of the time you are not that lucky. You will get placed on a shared server by the IT department, and typically, at least if you work in shops that I work in, you will not get a shared server that is used for light tasks. You will get a shared server where you do your continuous integration builds, where your actual application runs, and where you run the load tests. So it will be kind of heavily utilized. And also, if you run your load test on the same server where the application is, it will use the loopback network interface, which is orders of magnitude faster than actually going out on the network. So the tests will be bad, and you can't really trust your results. So that's no good. Another alternative is to use the developer workstations. So you could install some software on all the developer workstations, and you could control them from somewhere, and you could run the load tests on those machines. That's great. There are some problems here as well. In some organizations, the developers are not allowed to install software on their machines, and getting the permissions might take some time. Also, it is quite common for organizations to push out updates and restart the developer workstations in the middle of the night or something. And you don't want that if you are going to run long-running tests. Also, the developers are not very happy if their perhaps already slow machines get bogged down by the load tests. So, preferably, we did not want to do that either. So, how about the cloud? Well, the cloud is a great solution for some, not for us. You can set up a cloud test for a web application in minutes, and then you can run it, and it's normally very cheap as well. There are canned reports you can use to analyze the results. But there are some drawbacks. The main showstopper for us was that we could not allow the cloud tests in through our firewall. That would have taken a very long time to get permissions for that. Also, if you want to run a load test with this kind of concurrency for several weeks, it is quite expensive. Using Amazon's services, we would have ended up at about $16,000 for 1 month, which is a lot. And also, while it's very quick to get up and running with HTTP tests, if you want to test a custom protocol, you still have to write code for it and deploy it to the cloud service and so on. So then I thought about, hey, why can't we build a wall with Raspberry Pis? That's cool. And it has many advantages. You can put it inside the firewall, so the security department is much happier. They can block it off so that it can only access the server you're actually testing. You can build it quite cheaply with the right design. We'll get to that. And as the Raspberry Pi runs Java, we can take the load tests that we already had and just run them on the Raspberries instead. So no custom development there. And the tests are much more realistic because just like in the real world, you have many comparatively weak computers with many network cards connecting to one powerful server rather than one powerful server connecting to another powerful server. Just for reference, if you don't know the Raspberry Pi, it's not a performance monster. It's about as powerful as a 300 megahertz Pentium 2. It has a very good graphics card, but we're not using that. So that's about what you have. Also, it has no battery-backed up real-time clock, which we will come to in some time. So, we'll go through the design, the construction, the installation and configuration activities, the framework support, and cloning and individualization. To start with the design then, the point here, if you want to keep the cost down, is to keep the peripherals down. Most people who buy a Raspberry Pi for themselves at home start with a Pi. Okay, it's $25. Then you buy a case, and then you buy USB cables, you buy a USB hub, and you buy network cables, SD cards, etc., etc., etc. And pretty soon it's some real money there. So we wanted to avoid that. So we bought the Raspberry Pis. We soldered the units directly to a power supply, and you can actually see this here. We have a small power supply on this travel wall. It goes up to this connector here so that I can easily plug out a single unit without plugging out all the others. And then there are thin cables going all the way up to Raspberries, and they are soldered on the backside of it where the USB cable normally comes in. We bought memory cards for about $10 each, and network cables. We could have done them ourselves, but wasn't worth it. The most expensive part is the switch. For small walls like this one, we can use very cheap consumer-grade switches, so that's no problem. But if you scale it up, there comes a point where the switch suddenly has an enterprise price tag. And then the switch is so expensive that it costs more than everything else combined. So we wanted to find the sweet spot in between, where you have a pretty large switch, but not so large that it's enterprise priced. And it turns out there is one such switch. We found it, and the other group, which I think was up in the exhibition hall, that have built a cluster with 48 Raspberry Pis, also found it. It has 48 100 megabit ports that we can connect the Raspberries to, and it has 2 gigabit ports that you connect to the server you are trying to test. And this is basically, if you want to have many Raspberries, you have 48. If you need more than that, well, the next logical step is to take 2 times 48 and have 2 switches. All in all, we ended up paying about $3,000 for 48 units here. When we did this some time ago, we had to choose which Java version to use, and the choice was basically between free and fast. At that point in time, Java SE8 Embedded It supported hard float, which is hardware floating point. If you want to do decimal calculations, you can get hardware support for that on the Raspberry. It was the fastest out there, but it was not legal to use it in production. I don't think it's legal today either. And you could not even evaluate it legally on more than one device at a time. So that was out. Java SE 7 embedded only supported soft float back then. That is, all floating point calculations are emulated in software, which takes more time. And it had to be licensed. You had to pay about 20 cents per unit. That is not much money, but the administration of contacting an Oracle salesperson and getting a support contract and everything for this was a hassle. OpenJDK was free, and it had several different runtime engines we could use. But as you can see from the chart up here, it's much slower. If this simple test case, which is mostly CPU intensive, it required 20 seconds on JDK 8 or JDK 7, but with OpenJDK on the slowest version 0, it took more than 120 seconds, and even on the fastest OpenJDK, it took a little bit more than 40 seconds. So it's quite a performance difference there. Luckily, starting from September last year, Oracle has released Java SE 7 for Raspbian, and you can use it without having to pay them a particular license. So that's great. So by now, this would not be anything to think about, just use Oracle's JDK. It can be interesting to see that Oracle's VM is still the fastest in more realistic tests. Here we are using a single Raspberry unit, and we are running the use case we actually do want to run. And a single unit then, in 1 minute, can generate about 1,200 business transactions on Oracle's Java 8. Whereas if you use the fastest OpenJDK engine, it can generate about 600. So Oracle's VM is about twice as fast, which is interesting considering that most of the code in OpenJDK and in Oracle's VM is the same, still. We got some problems with the Avian engine that we started out using. It would crash on us, so we picked JamVM in the end. One thing we ran into was that the old Java SE 7 VM only supported soft float, and all the recent kernel versions, all the recent operating system versions use hardware floating point. So if you want to run the old version of Java SE 7, you had to install an older kernel version. And that is still true today if you use some other program that has dependencies and cannot work with hardware floating point. They did something rather evil, in my opinion, from Raspberry. They released a new version of the Raspberry Pi, but using the same numbering. So we have the Raspberry Pi Series B, and I have 2 different units of that. One can boot up a soft float kernel, the other cannot. And the reason is they switched their memory controller and used the Hynix memory chip. You can see that by looking at the square chip in the middle of the Raspberry up there. It says Hynix or Samsung if it's the new chip. And in that case, the old software kernel would not boot. Luckily, you can fix that by replacing 3 files in the boot partition. It's start.elf, bootcode.bin, and fixup.dat. Yes?
That wouldn't be a problem with a recent Raspberry and kernel?
No, all the recent kernels have hardware floating point. It's just if you need to use some software that depends on the soft float kernels, then you need an old kernel, and then you would have this issue. But all the modern kernels support it, so it should have no problem. We actually got 47, yeah.
You have a problem finding a supply where you could go and get like 48 or more Raspberries with the same chip configuration?
The question was, did we have problems finding enough Raspberries with the same chip configuration? And the answer is, we probably would have, because the suppliers don't know what they have. We got a batch with one of the old and 47 of the new, which meant that when I started our wall, after all the soldering and screwing activities, 47 units failed to start, and I was, oh, God, have I broken it? But I hadn't, so we got that sorted out. Otherwise, one of the good things with the Raspberry is if you want to order many Raspberries, that's possible, because there is such a big demand for them, so you can just go to a normal electronics shop and ask for them, and with a few weeks they will give it to you. Okay, so we built a prototype using spare parts first. We had a PC power supply. It could support about 35 Raspberries, and we used a design similar to this one. Unfortunately, the 35 Raspberries could not give us the 100 business transactions per second with SSL that we were looking for. So we bought a BigA Wall, which is this one. Here we have 48 units. Again, power is soldered on the backside, and it's routed to the metal box below there. And we have the big switch I talked about that can support 48 units with 2 gigabit ports to the other side. And it works quite well, actually. Over to the installation. The installation is straightforward. When you use the older soft float kernel with Oracle's JDK, it was a bit messy. But now what you do is you download the latest kernel version from raspberrypi.org downloads, and you write it to a memory card. I've used the syntax for Linux here. So sudo dd if and the name of the image, and of, and in my case dev sdb. Block size 1 meg. It's important here that SDB happened to be the second disk on my machine. That's when I plugged in the memory card. On your machine it might be SDC or SDD or something else. So check when you plug in the memory card where it is, so you don't write to the wrong device. Also we write to SDB, which is the entire disk, not SDB1, which is the first partition on the disk. So some people write to the partition and then things won't work. It won't start. When you have the memory card written, you can just boot it up and connect using SSH as Pi with password Raspberry. And this is very good because in the old days, the SSH server was disabled by default, so you had to use a keyboard and a console the first time around. You don't have to do that anymore. When you're logged in, you can do sudo raspi config and run the configuration program. You might want to expand the file system, it depends. Keeping the file system small means you will have a smaller image when you copy it to the other cards later on. Extending it means you have more disk if you need that. You will want to disable boot to desktop. We're not using X Windows here. Overclock, probably. We went for medium. I will get back to that in just a little while. And under advanced options, you will definitely want to give as little memory as possible to the graphics processor, because that means more memory to Java. Then you might want to edit etsntp.conf and register a custom time server. Because, as I said earlier, the Raspberry Pi does not have a battery backed up clock. So when I power it on, it believes that time is what it was when you powered it off the last time. So the first thing it does, it tries to connect to a time server. If it has an internet connection, fine, it will find it. If it doesn't have an internet connection, and it gets its IP address from a DHCP server, that DHCP server might also point it to a NTP server that it can use, and then you're also set. But if you're using a Windows DHCP server, for instance, that doesn't point to an NTP server, you need to manually tell it where it can find it.
How long will it take for it to catch up with the current time?
Well, normally quite fast. It depends. If you have it so that when the power comes up, it can immediately find its time server, it's less than a second. But if it misses, it will not continually bombard the time server, and then the time between each query will be longer and longer. So then it can take a few seconds or a minute.
Make a jump for current time, it incrementally goes towards current time.
Yeah, but it will make a large jump the first time because it knows it's off. So it usually works out quite quickly. Okay, right. So then what you do is you reboot to get your changes in, and then you update to the latest packages with sudo apt-get update and upgrade, and then you install Java. And the command I've given here, sudo apt-get install Oracle Java 7 JDK, installs Oracle's Java 7, which was not possible back when we did this, but if you're doing it now, that's what you want. Lesson learned, it's good to buy high-quality SD cards. We've had this up and running for not quite a year, but almost a year. And during that time, we have broken 15 file systems, and 4 of the SD cards are dead, cannot be used. And the reason probably is that we used cheap class 4 SD cards. Not a good idea. Buy the class 10 ones instead. There's a little price difference, but it's well worth it. Also, you will want to disable writes as much as you can, because it's the writes that destroy the SD cards. In particular, if it happens to write to the SD card when you break the power, then you have a problem usually. So you want to minimize writes, so start by disable swapping. The Raspberry actually doesn't swap unless it has to. And but in my case, I would rather have the program crash than swap, because swapping is not good for the SD cards. So I usually you do sudo defuse swap file swap off and uninstall, and then deregister it from the running services. Also, there are several cron jobs by default that you don't need. You don't need to update the man pages every day, and you don't need to connect to the internet and download new packages or something, because you will be doing that manually when you need it instead. So those go away. Then one very useful thing is to edit its FS tab and create a file system for var log, so that all logs go to RAM instead of to the SD card. And when you're at it, you can add the no rtime directive to all the file systems there. Because if you don't, every time you access a file for reading, or for instance, it will record that you have accessed it, and that's a write. So that's a good best practice. And you might also want to edit etsrsyslog.conf so that you don't fill up the RAM disk with unnecessary logs. Okay, overclocking then. Should you do? The Raspberry config tool has 5 predefined levels. It has none, modest, medium, high, and turbo. And most people can use one of these levels. It's also possible to fine-tune lots of things, voltage levels, different frequencies, and so on. I wouldn't do that, but it's possible if you really want to get your hands dirty. Overclocking does make a difference, as the chart here says. You can see that without overclocking, my simple test case took a little bit more than 25 seconds. With the highest overclocking, it took about 17 seconds. So you do gain some. But there is a drawback, and that is when the risk for destroying your SD card or the file system on your SD card increases a lot with overclocking. In particular, with the highest level of overclocking, many people have reported that even class 10 SD cards get corrupted. So I would not go for turbo, but high perhaps, or in our case we went for medium to have some margins. It's not fun to replace SD cards too often. Overheating is another issue, but here in Sweden, I mean, we've never even been close. So I wouldn't worry about overheating, unless you live in some warmer place. Next thing, frameworks. What should you use? And the good news here is that the Raspberry is actually quite good. It supports your load test framework of choice, I would say, unless you have very exotic tastes like CNTLM or something that use native code. But as long as the framework is 100% Java, it will probably work. We had existing tests using Grinder Free, and they worked out of the box, so that was very good. In general, I would say that is the way to go, because then you can record your tests, in particular if you're using HTTP, and just edit them and use them, and you're up and running very quickly. Also, the tests are portable, so you can run them on the Raspberry, or you can run them somewhere else, or mix and match. I like to program. So I actually used my free time in the evenings to write my own load test framework. That way we got rid of the Jython engine, much fewer classes, a smaller footprint, and we could simulate several clients using the same thread, less context switching and more performance from the Raspberry. But if that had been the client paying for that time, I probably wouldn't have done it because, well, the grinder was good enough. Simply add a few more Raspberries instead.
Is it public?
Well, kind of. I haven't released it, but it's not proprietary in any way. So if you're interested, certainly. Okay, installation and configuration takes time, so you only want to do it once. So install and test on a single Raspberry, and then when you're happy with it, just turn the dd command around and copy the memory card to an image. And then you can copy that image to all the other cards. And when you're done, you can start everything up, and you can use a script that uses SSH to log into each unit in turn, and set, for instance, the host name so that it becomes unique, if you want that. It's not necessary, but it makes it easier to see which Raspberry has failed if you need to do that. And also the image is an excellent backup, so keep it, because if your memory cards go away, it's good to be able to burn them out again without having to do anything. So what about load test then? What is a load test? Well, a load test should determine if your system meets its performance requirements. So the first thing, of course, you have to do is to determine the targets. Not all projects have performance requirement targets, but it's a good thing to start there. Then you can generate load, and that's where the Raspberry Wall comes in. And in order to see if you meet your target, you need to measure, and finally analyze the results. In our case, we needed to have 50,000 concurrent connections, long-lived connections. We needed 100 business transactions per second with SSL. We needed stable performance over time, few or no errors. And we needed to run for at least a week, preferably longer. And we could start up the wall slowly so that it could ramp up the requests without killing the server. Many servers start small and then they add resources as the load goes up. So if the load comes, bam, the server properly dies. So ramp it up slowly. It's very important to measure the times and failures on the client, because if you fail to connect, the server will never see it. So you need to measure connect times, you need to measure response times, and you need to measure possibly if you have many requests with the same connection, you need to measure the individual steps so you can see where the bottlenecks are. And it's also a very good idea to use a performance monitor on the client side, in particular with the Raspberry. You don't need to do that on all the units, but if you run top on one of them, you can see that it's not completely bogged down. If it is, ease off a bit, you will get more performance if it's slightly lighter loaded, so that it's not context switching all the time between different threads. Then when you have the tests humming along, you can disable logging on the client side. You know about how much it performs, and disabling logging will mean fewer writes and better performance. It's very good to instrument the server. So if you build the server yourself, think about this from the start. I always try to instrument my servers so that they have a cheap way of measuring performance that can be enabled in production. And in this case, we measured the total number of successful business transactions, the total number of errors, the total number of active connections right now and active threads right now. All of these things are fairly cheap to do. And then we log that out once a minute to a log file, also very cheap. Also, we had the possibility to enable detailed logging for each individual requests, where we would measure SSL handshake time, connect parsing time, and all the different sub-steps of actually doing the request and returning the results. And that's very useful if you need to analyze where the bottleneck is. A bit expensive to keep that enabled all the time though. With or without instrumentation, you need to measure both the server performance and the JVM performance when you're running the tests. And most operating systems, if not all, have good performance monitors. The one I'm showing here is from Windows 7. It's quite good, and there are similar ones for all the other operating systems I know of. The window to the left is JConsole, which comes with Java SE 7 out of the box. So use it. It has many good things you can look at. Thread utilization, garbage collection, you can get graphs and lots of other things. With the recent versions of Java SE 7, you even have mission control, which is like JConsole on steroids. So even better, use mission control if you have it. Of course, when you connect JConsole or mission control to the JVM, performance goes whirr. It doesn't kill it, but it definitely goes down. So you don't want to run the entire test with JConsole connected. But it's very good to run a shorter test with JConsole and see what the bottlenecks are and how the JVM is behaving. Another very good tool, which is free and comes with Java SE 7, is Visual VM, which is a profiler. A profiler shows you how much time is spent in different methods. So you can see if a method that perhaps is fairly efficient, but which is called several thousand times per second, and another method is fairly slow, but it's only called once per application run, you should probably focus on optimizing the method which is called often. And that is what the profiler helps you with. It shows the total time spent in different methods. So it's very, very valuable. It also brings performance down, so you cannot run the entire test with it, but connect and see how things are going for a shorter test. Well then, if the targets are met, the test was a success and you're done. If not, hopefully the problem will stand out either in the profiler or in the logs. So one thing to prepare for is to have the logs in a format that you can import into Excel or into a database or something so that you can analyze them. Some issues are JVM or platform specific, so it's a good thing to test the application on multiple platforms. We actually had a fairly evil problem that only occurred on Windows. And as we also tested on Linux and Solaris, we knew that the problem was not in our code because it ran fine on Linux and Solaris. So that was good. And Google is your friend. Often other people have had the same weird problem that you are staring at, so search for it. Now I thought we would make a live demo. Hopefully it works this time. Usually works. So what I've done here, I have fired up the wall. So on each of these Raspberries, I have a grinder agent running. A grinder agent is a JVM. And when it starts, it can run standalone as well, but when it starts in this case, it tries to connect to a console, which I have running here on my laptop. And under the Processes tab here, we can see that we have 6 Raspberries connected. So all the agents are just waiting for me to tell them to start working. I also have a local Tomcat running here on my laptop. And it has a very simple and rather ugly web application here. It tells me to enter a Giro number, which is a Swedish bank account number of sorts. And I do that. And then I validate it, and it will tell me if it is a valid Giro number or not. Here it's not. So I should change the checksum to 0. And this is indeed a valid postal Giro number, which should be formatted like this. So it's a very simple application. It doesn't use a database or anything like that. I had a test application previously which connected to a local database, but even with only 6 Raspberries, I could kill that one too easily. So this is more robust. Okay, So I will start the agents, and this is something, it asks me if I should send out the software to the agents so they are running with the latest version of the code. Yes, please, do that. And then we will wait for approximately 1 minute when Grindr fires things up. So the first times I had this talk, it was a nervous wait, but now I know it will take about 1 minute. So in the meantime, we can look at the script here. This is Grindr, so it has a tool that makes it possible to record scripts. The scripts are JSON, so it's a sort of Python. And the tool actually writes something like this, so you can just make normal web requests that are recorded, and you end up with a JSON script that looks something like this. You don't need to look at the details. It's fairly ugly code, but it's very easy to edit and make it more generic. So it's a very good starting point for testing web applications. And then there are properties as well that tell you how many threads to use and things like that. And I can see here on the left that some of the agents have started working. So we'll flip to process again. Here we can see that we have some of them have started, but so far only 3. So, well, the others will soon be up as well, I think. On the results pane, you can see there are 3 main parts here. Getting the home page, which gets the home page and also some CSS and images, and validate an invalid gyro and validate a gyro number, and you get all sorts of valuable statistics for each. And yeah, sooner or later this should be 120 threads, and everything should hum along. But as I said, the start time for there was another one and there was another one. Yeah, 120 all are working. The start time can be a little bit frustrating at times when you just want them to go at it. Okay, any questions about the live demo before? Yes?
No, I had questions about the topology.
Yeah, shoot.
I was wondering, you explained about the SD cards and the writes and the problems connected with that. Have you considered have an SD card that does a remote boot and you have some kind of NAS that collects your logs and contains the images for booting?
Yeah, the question was, have you considered just using some kind of remote boot solution and connecting to NAS or something in order to store things instead of using the SD cards? Yeah, well, we have considered it a little bit. We didn't go with it because we didn't find out about the problems with writes until a bit later in the cycle, and then the solution was already up and running. So you can do that. You can run also what we have considered is running with a read-only SD card, because you can get everything up and running. If you disable logging and disable all the other things, you can just let the writes fail if there are any writes and run read-only, and then you have no writes. So that would be an option. But as we at least sometimes want to record logs on the client, we do need to write them somewhere. And yeah.
But you have a switch and you have a network connection. So
Yeah.
it's disconnected to the switch.
We could do that. We could do that. But answer, no, we haven't. Okay. In that case, I will simply stop the workers, and I will stop collecting statistics and go back to the presentation. There we go. Okay, so what were our results? Well, to start with, the load test made a difference for us. We found and fixed some issues. We profiled and found a bottleneck in the custom lightweight SOAP implementation that we had built, and fixing that helped a lot. Profiling also told us what we didn't need to know, because after we fixed that, almost all the time was spent SSL handshaking and parsing XML, and neither was in our code, so that was good. We had some issues with full GC pause times, and that is a difficulty for many applications if you want to have quick responses, and then suddenly you have a full garbage collection that takes several seconds. Not acceptable. So we had to tune that. We got slightly worse throughput, but we got much shorter pause times, so we got rid of all the errors there. And then on some platforms, Windows, the performance would degrade over time quite a lot. And eventually we managed to tweak around that with JVM settings as well. So we solved that, and we could run, after having run for 2 weeks without any issues, we knew that, okay, this has been fixed now.
Are you running 2 weeks on a Windows machine?
Yeah.
Without running out of ports?
Yeah.
Amazing.
Okay, so we reached our targets. We ran with 90,000 concurrent connections, long-lived connections, and a little bit more than 100 business transactions per second, and I think this graph is for 2 weeks. So we were very happy, and the customer was very happy as well. And to sum it all up, I think the Raspberry Wall works well as a load generator. It was very fun to build it, and we are putting it to good use. It's working for us right now. There have been no real issues except for the hiccup with the Hynix memory chip and the soft float kernel that didn't support it, and the OpenJDK Avian crashes. In the long term, cheap memory cards are a hazard, so as I said earlier, buy class 10 cards if you can. Much better. Good thing, you can use the normal Java load test frameworks. So just take the one you're familiar with and go. And the platform seems to get better all the time. So there are new updates, new features, and the documentation on the internet is also very good. That's one reason to choose the Raspberry. I always get the question, why did you pick the Raspberry? Why didn't you take the Beanie or one of the other boxes? And the answer I always have is the Raspberry is so much more widely spread. So if you find something that doesn't work on it, you can just Google and you will find it, which is not always the case with the other ones. And we are very happy that Oracle have decided to release their Java version so that it comes out of the box with Raspbian, because it makes things very much easier. And with that, I'm done. So, yeah.
You don't use any casing for the Raspberries.
No.
Have you had any problems? How about short circuits and dust?
I'm happy to say that we have had no problems with that. We have had problems with the SD cards, but we have had no problems with the Raspbians breaking down. So they are sturdier than they look, I would say. Anyone else? Yeah? Oh.
Do you have any published instructions how to set it up?
Well, this presentation is available from my blog, and it will also be available from JFocus. So the easiest way is probably if you look in JFocus in a few days, it should be there. And if you need more instructions, you are welcome to contact me. My contact information is in the presentation as well, and I will be glad to help. Let's see, yes?
Do you have any pointers to how much load you can generate with that setting you have right now?
It depends very much with your application, I would say, because one thing, I don't remember if I said this, so excuse me if I'm saying it again. If you have a single Raspberry and it can generate 4 business transactions with SSL, it can generate 120 without SSL. So your first question is whatever you are doing CPU intensive. Because the Raspberry, it has a good network card, but it has a very slow CPU. So if you're using encryption or something like that, then it's slow. If you're not using encryption, it's probably much faster. So it's very, very hard to say. Okay, then I say thank you for coming.